Let's see here. If I turn that down for me... This is gonna be a weird one. I've been meaning to start reading through a lot of the Godot documentation for ages, but I've never had the motivation, unfortunately. I'm very bad at doing things on my own. So we're having a strange stream today, where I go through and just read through all of the documentation here. Hopefully you can hear the music I've got playing in the background a little bit, so it's not just me talking constantly. Or maybe you just prefer me talking constantly without the music in the background. Either way, let's see here. Introduction page, get an idea of what this has to offer. Oh, we're gonna get to that anyways. Getting involved, free online, can download a local version. I already did, though it seems like this version is effectively the same. From all devices, okay, that's just for that. And then here's the introduction. Let's actually, this just goes to the, yeah, that just goes to the same thing, okay. Hello world. Okay, you can choose C# or Godot. I've been learning mostly Godot script. I know C++, Python, and JavaScript. That unfortunately doesn't cover C#. It seems pretty close to JavaScript, actually. Comma at the end, brackets. Public override isn't part of Java. But I'm probably going to stay on GD script. It's closer to Python, which is a lot easier. Welcome to the official documentation. Powerful user tools. Gives a broad overview on where to start if you're a beginner looking for information. Lists tutorials given by the community. Interesting, we'll keep that open. If you prefer video to text, consider checking them out. Otherwise, getting started is a great starting point. Let's see here, are these just... Yes, these are just linking to different parts in this. Down here. Let's keep that open just in case, so we can see what order I want to go through. I was thinking of just trying to brute force this whole thing in direct order, but it might be nice if I jump to the getting started instead of reading through all of this. And I doubt I need to read the changelog since this is the most up-to-date version. Projects, you can find community channels, Discord, or the forum. About Godot engine, complex tool, difficult to present in a few words. It's feature packed, yep, this is just information, open source, no royalties, free to use, independent, non-profit. About contains an introduction as well as information about the engine, its history, its license, authors, etc. And frequently asked questions. Okay, that's good. Getting started contains all the necessary information for using the engine to make games. Starts with an introduction. This is the best place to start if you're new. Manual can be referenced as needed. In any order, it contains feature-specific tutorials and documentation. Engine details contains sections intended for advanced users and contributors with information on compiling the engine, working the editor, or developing C++ modules. Community, dedicated to the life of Godot's community, with third-party tutorials, materials outside of the documentation, and provides details on the asset library. Godot communities, which are listed on the Godot website. Finally, the class reference document, the full Godot API, are also available directly within the engine script editor. You can find information on all classes, functions, and signals here. So this is going to be the really important thing. Class references, and probably the manual? Yeah, manual and class references are going to be the actual important things for figuring out what we're doing. Organization, already read this, about the documentation, always looking for more help. List of features, supported by Godot platforms, can run on all three, Android and browser. I've seen it run on browser, I shouldn't be surprised by that. Can be exported to iOS and councils, yep, I remember that update happening. Exported to new platforms with ease, projects in C#, cannot be exported to the web platform. To use C# on that platform, consider Godot 3 instead. Interesting. Godot 4.2, but is considered experimentation. Yep. Scene editor, built-in script editor, supports external script editors such as Visual Studio Code or Vim. GDScript debugger supports debugging threads available. Visual profiler with CPU and GPU time. Options for each step of rendering. Live scene editing. Remote inspector. Camera applications. Built-in offline class reference documentation. That's what I've downloaded for if it needs to be offline. The editor in dozens of languages. Yep. Plugins. Rendering. Ooh, rendering. Desktop platforms for Vulkan. Okay, it's just for which system you're trying to use it to. GPL, rendering methods, 2D graphics, tools to draw polygon 2D and line 2D. We'll get to those eventually to support texturing. Animated sprites, yep, it's complicated how they do it, but it's certainly there. Parallax layers, yeah, it would have to be pseudo 3D, I think, the way they handle things. 2D lighting with normal maps and specular maps. Rendering. Apps. Dynamic flows. GPU and particles. Ooh, particle shaders. Tile maps. I need to learn how to do tile maps. 2D physics. Yep, static bodies. Those are all of the basic ones that you can just apply to different objects. Built-in shapes, line box, circle capsule, world boundary, infinite plane. This does not seem to be exactly what I'm looking for, but I'm still just giving it a skim. Directional lights, up to 4 per scene. Interesting that there's a limit on those, though it seems it's saying specifically global lighting up to 4 per scene rather than built-in lighting that you've coded. Yeah, this part I'm just kind of skimming through. Voxel-based. I didn't realize it had built-in ways of doing reflections. Design distance, voxel-based rendering. Visible on transparent surfaces. Interesting. Optional enabled. Mixed together for greater accuracy. Desktop. Interesting. I'll have to remember that. I had an idea for something easy I wanted to do, but it was going to rely heavily on reflections and kind of portals, which you might be able to do with a form of decal. But I think reflections is the easiest way to work with what I wanted to do for my one of the smaller projects I wanted to work on. Roughness. So I should actually read this properly. Voxel-based reflections. Distance fields, voxel-based reflections are visible on transparent surfaces, while rough SDF-based reflections are visible on transparent surfaces. Voxel-based reflections are visible on transparent surfaces, while rough SDF-based reflections are visible on transparent surfaces. Something's worded wrong here. I feel like one of these two isn't supposed to be visible on transparent surfaces, but they accidentally typed the same thing twice. Fast-baked reflections, slow real-time using reflective probe, parallax box correction can be enabled. Screen space reflection with support for material roughness. Reflection techniques can be mixed together for greater accuracy. When using default render on PC, reflecting probes are rendered with clustered forward optimization to decrease their individual cost. Clustered rendering also lifts any limits on the number of reflection probes that can be used in a mesh. Reflection probes. Gonna have to look into that. Just gonna make a whole tab of just terms I need to look into what they mean. While using the mobile render, up to 8 reflection probes can be displayed per mesh source. When using the compatibility render, up to 2 reflection probes can be displayed per mesh source. So I guess each object can have 2 reflective surfaces on it, and mobile can only render 8 reflective surfaces at a time. Interesting. I guess that kind of answers my question on what a reflection probe is. Decals. Okay, upscaled. Okay, decals definitely aren't one of the things I'm looking for because they seem static. Yeah, they're static by the sounds of it, so I wouldn't be able to use them. Sky. Yep. Fog height. Interesting. Volumetric fog. Sounds like interesting. Particles. Base particles. Tractors 3D only. Particles. Texture compressions, slow but results in smaller files. Okay. Probably gonna, I don't know. Anti-aliasing. Ooh, I actually need to read how Godot does resolution scaling support. For rendering at 3D at lower resolutions with keeping 2D rendering at the original scale, this can be used to improve performance on low-end systems. Resolution scaling uses bilinear filtering. DSS superiorization. Texture map, log basis, scales can also be modified with a manual offset. Well, this isn't exactly what I need actually, but I do need to pay attention to resolution, because any game you make, you need to figure out how you're gonna have it scale in resolution. Like if I take this here and computer lagged a little bit, and just drag it, you can see how all of the text automatically fits to try to fit on the screen. And when I get it far enough, this little side appears. And then eventually, once it's far enough, everything just starts organically centering. That is something that needs to be programmed. And that needs to be programmed for any game that is being made. Otherwise, it's just going to be a static square where even when someone, say, full screens it or runs it on a different size screen, it will always be usually either the same amount of pixels or some other measurement, just a certain size large, no matter what someone does to it. Any game that you can hit like Alt Enter or full screen in has had programming to let you do that. Some games, to an extent, have it baked in, depending on the system. I think Godot has a not too functional built-in way of doing it, but it doesn't scale well if you use the built-in way, which means you probably have to program in how you want it to scale. So I gotta keep that on mind. Built-in meshes for tours and stuff. Grid maps for 3D design. Tools for procedural generation. Path nodes, that's nice. Supporting expand projects, 3D physics, static bodies, animated bodies for objects moving only by script or animation, such as doors and platforms. Interesting. So these are like dedicated, you want something to have an animation, then it's an animated body, but it's not going to have like any player input. Well, I guess it could have player input by a script. Rigid bodies, character bodies, vehicle bodies. Intended for arcade physics, not simulation. I wonder what that means. Joints, soft bodies, ragdolls. Areas to detect bodies entering or leaving it. That is a great thing to have by default. I've programmed those before and oh my, it's a hassle. I guess it wouldn't be that bad even if it wasn't already built in, because you could just make a static body without collision and then attach a script to it that detects it, but it seems like this just skips that step to make it easier. Built-in shapes, yep. Generate triangle collision, shaders, scripting, object-oriented design, scripts extending nodes, yep, that is what happens in the editor. Signals and groups for communicating between scripts. Don't know what the groups is, but I have some guesses. Supports for cross-language scription. Okay. High-level interpreted language with optional stylistic typing. Syntax inspired by Python. Yep, I called that. However, GDScript is not based on Python. Good to know. Syntax highlighting is provided on GitHub. I might need to download a separate highlighter for the syntax then. Use threads to perform synchronous actions or make use of multiple processor cores. Ooh, that's a bit above the level that I'm gonna need to work with, thankfully. Sharp package. And a separate binary to keep files. Okay, this is just for if you wanted to optionally use C# to compile things. Web platform is currently unsupported to use. Oh, it's just saying unsupported for C#. When you need it, link to native libraries or higher performing third-party script, game logic, GDScript, or C# recommendations if suitable. Mono stereo, non-positional. Polyphony. I am not an expert at sound design. Support for random volume and pitch. Well, theoretically, you could just program the random volume and pitch. I guess what that's saying is your scripts can interact with different aspects of audio that you've imported. Yeah, that's what this is saying. Interesting. Procedural audio generation. No support for MIDI yet. Interesting. MIDI output yet. So theoretically you can still input MIDI. Yeah, theoretically you can still input MIDIs. Like make a MIDI file and then integrate it into the project, but you can't make a project that directly exports a MIDI file, probably without a lot of a lot of programming. I mix up back end and front end, so I'm not gonna say one and then probably say the wrong one. Import supports custom plugins, formats. Input mapping using a hard-coded input events or remappable input actions. Yep. Map to two. Axis can be mapped to two different actions with a configurable dead zone. Keyboard inputs can be mapped in physical mode and be independent of the keyboard layout. Mouse cursor can be visible, hidden, captured, or confined within the window. Well captured raw input will be used on Windows and Linux side stop or the OS mouse acceleration settings. Okay, so even if someone has mouse acceleration on, it only uses raw input for mouse capture, which is interesting. Yeah, no, that's interesting. I mean, it shouldn't cause any issues, but it might mean that, like, if you wanted to do a first-person game or, like, a shooter, it would be a lot harder to allow people to have custom sensitivities. Like, there are certain ways you can have custom sensitivity curves on your mouse and stuff like that. This says by default, unless you do some coding, everyone will just have essentially a flat curve, no acceleration. Navigation. Networking. I don't care much about networking because I'm not planning on doing multiplayer stuff. Use localized strings in your project automatically in GUI elements or by using the true function. What would that be? Interesting. Support pluralization. This is translations. Oh, this is for like internationalization. Okay, I misread that word. I read it as internalization. And I was like, what in the world is this section going to be about? But this is just how you can, baked into your program, have multiple languages supported, or prepare preemptively to have multiple languages by coding it in a certain way. I'm doing an OS integration. Spawn multiple independent windows. That's cool. Move, resize, minimize, and maximize windows. Change the window title and icon. Request attention. Interesting. I didn't know that was a thing. Full screen. Use borderless full screen by default on Windows for fast alt tabbing, but can optionally use exclusive full screen to reduce input lag. Borderless windows. Ability to keep windows always displayed on top. That sounds a little nasty. I don't like games that force the window to always be on top. Looks at you, old Bethesda games. Global menu integration. Execute commands in a blocking or non-blocking manner. Multiple instances of the same project. Open file paths. registered on the system. Parse custom command line arguments. Wow, these are getting into virus territory where you get like a Windows pop-up. Hey, we aren't sure about this thing. You might want to be careful about running it. Any binary. Any Godot binary editor or exported project can be used as a headless server by starting with the --headless command line argument. This allows running the engine without a GPU or display server. Interesting. I don't entirely understand what that means, but we're gonna say interesting and move on. This is AR and VR, user interface, global user interface? I should know this. GUI, GUI, general user interface, is built in using the same control nodes used to make games in Godot. The editor UI can be easily extended in many ways using add-ons. Yep. Buttons, checkboxes, text entry using line edits, drop-down menus using pop menus, option buttons, scroll bars, labels, rich text, trees can be used to represent tables, color picker with RGB and HSV modes, controls can be rotated and scaled, sizing, centered, stack, grid, flow, resolutions using scale to multiple resolutions using the canvas items or viewport stretch modes. Let's copy and paste that to remember it. For any aspect ratio using anchors in the expand stretch aspect. There's probably a better way for me to keep notes like this. Built-in theme editor. Direct kinematics and inverse kinematics support for animation, any property with customizable interpretation. Support for playing sounds and tracks, support for Bezier curves and animation. Can be saved in a text-based or binary format. Text-based formats are human-readable and more friendly to version control. Binary formats are faster to save or load. Read and write text or binary files using file access. Interesting. Can also be compressed or encrypted. Read and write JSON files, read and write mini files, XML, PK files, export additional packs. Oh, interesting that there's direct video playback. Interesting. Didn't know about that. Low-level access to servers, command line interface. Direct features, create smaller word tables, support C++, yep. Built-in modules can be disabled, compiled, C optimizing. Engine editor written in C++ 17. Okay. System requirements. These don't mean much. Warning here. Requirements below are baseline for simple 2D and 3D projects with base scripting and few visual flourishes. GPU, RAM, and storage equipment will heavily vary depending on the project's scope and renderer, viewport resolution, and graphics settings chosen. Other programs running on the system with the project is running will also compete for resources. Yep, that is basic stuff. Don't need to check those because I know I can run it. Okay. Frequently asked questions. What can I do with Godot or licensing terms, we know that. Which platforms are supported, already read that. Which programming languages are supported, already read that. Why is GDScript and why should I use it? Don't need to know that. What are the motivations behind it? Good for you. Which programming language is fastest? Binary, kind of. Probably, what is it called? Command line, but I don't think GDScript uses those. C++ and C# are probably closest after that. Common C++, so you don't need to worry about that. Which 3D model formats does Godot support? You can find detailed information on how to export them from 3D modeling software and how to import them for Godot in the Importing 3D Scenes documentation. We'll get to that. Will insert closed SDK such as Fmod, GameWorks, etc. be supporting Godot? The aim of Godot is... Okay, SDKs supporting Godot. This is will integrating other text editors, SDKs, or code editors, be supported. There are no plans for them to be supported, especially if they are a closed or proprietary SDK, as integrating those would go against Godot's ethos, essentially putting work towards text editors, code editors that you need to pay to get access to. Godot has no intention of making integrations for them. But because it's open source, someone else that's not working with Godot could always make an integration for them. How can I extend Godot? Plugins, how do I install? Editor on system for desktop integration. You need to don't run it. Means desktop integration is performed automatically. Yep. This is why if you're launching a HTML version of Godot, there's no like, oh, you need to download a version of Godot for it. It just opens. That is what that's saying, I believe. Is the Godot editor portable? Semi-portable. Can run from any location and doesn't require administrator. However, configuration files are user provide data. Configuration, okay, personal configuration can't be transported from one system to another. Vulkan OpenGL over Direct3D. And keep its core feature set small. Implemented by add-ons unless they're used very often. One example of something we used often is advanced artificial intelligence function. Oh, something that is not used often is AI. Good. Thank you. Why should assets be created to handle multiple How should assets be created to handle multiple resolutions and aspect ratios? This is something I'm aware of being an issue, so I'm going to actually read through it real quick, because it seems like they put some information there. Pops up often. The same assets in different resolutions is a good idea. Somebody into that's path. Run several Android applets with different resolution ratios. CPI. The most common proper way to achieve this is instead use a single base resolution for the game, and then effectively stretch different aspects of it to the other resolutions. Go up to 140p if you're down 40. Cost. Mirror. Yep, this is just general advice. Use the stretch option, which I already kept a note of. And there's a tutorial for it. Interface. Anchoring, determine controls, stay and move. Okay, for UIs, use the anchoring to determine what things should stay and move. Okay. If UIs are more complex, consider learning about containers. version should I use? Should I upgrade my project to use the new Godot version? Some versions are safer to upgrade than others in general. Whether you should upgrade depends on your project's circumstances. Okay. Should I use Forward Plus? How can I get started on contributing? I have a great idea. How can I share it? Is it probably... Yes, Godot features an extensive built-in UI system and small distribution size can make it suitable alternative to frameworks like Electron or Qt. Okay. For non-game development, is it possible to use Godot as a library? Godot is meant to be used with its editor. We recommend you give it a try, as it will most likely save you time in the long term. There are no plans to make Godot usable as a library, as it would make the rest of the engine more convoluted and difficult to use for casual users. Let me check something. What is making a engine into a library? With class of libraries being class libraries simply because they are within a game engine. A library is a framework tackle a specific need within a game engine. Interesting. Kind of understand. If you want to use rendering library, keep in mind rendering engines usually have smaller communities compared to Godot. What user interface does it make? Why does Godot use the scons build system? Why does Godot not use standard template library? Such as Thriving Primitive STL is a great general purpose library, but we had special requirements for Godot. STL templates create very large symbols which result in huge bug boundaries. We use very few templates with very short names instead. Most of our containers cater to special needs like vector, which uses copy and write data around, or system, which requires O1 access. Performance. Likewise, our hash map implementations are designed to integrate seamlessly internal type engines. Does this imply that other data around, or the RID system, which requires it seems to imply that other ways of doing this require more than O1 access time, which is interesting. For larger arrays, we use pool memory, which can be mapped to either a pre-allocated buffer or virtual memory, a la C++. Well, I guess you can't. Well, you can. You do need to pre-allocate, or else it gets messy. We use custom string type. It's one provided by STL. To basic support. Why does Godot not use exceptions? We believe the game should not crash no matter what. If an unexpected situation happens, Godot will print an error which can be traced to a script. Then it will try to recover as gracefully as possible and keep going. Interesting. Additionally, exceptions significantly increase the binary size for the executable and result in increased compile times. Interesting. I didn't realize Godot did this. When you are running a program, if it's not sure what to do, it essentially just crashes and sends out a string that is, hey, this is why we stopped running. You didn't do this right here. You messed this up here. But this is saying it won't stop running if something goes wrong as long as it can keep running. And it will just send a flag error report instead of stopping everything and giving you the error report. Does Godot use EC5? Does Godot not force users to implement DOD, data-oriented design? Yeah. Did I just... Oh, it's the bottom of the page. How can I support it? Who is working on it? How can I contact you? Complying with licenses. Not legal advice. Good faith to help users. Godot's created. You're not the sole owner. Contribute so contribution. You comply with its original one. Third party assets. Likeness. Require attribution. My feature software software is finished with foundations. Software. All kinds of software as it is without warranty and finally dealing with software. And uses from other third-party libraries. Not need to be under the same license. You're free to release Godot projects under any license to create commercial games with the engine. That is a good note to put there. Good clarification. Because I know some licenses say that you must have the same license on anything you make with it. In fact, the music I'm listening to is by a music maker named M that has a whole bunch of music, but has, if the music is ever like remixed, remastered, like if you take any of their samples, do stuff with it, then you need to be on an open source, free, I forget the exact licensing, but it's just like you can't, I'd need to look at it. But I know their licensing says you're free to use my music for anything, but you need to also let other people be free to use it, the music at least, if you put the remix or any changes to the music in anything. I did not describe that right, but close enough. Essentially, any licensing you do with the music has to have the same outline of the licensing of the music. That I'm doing poorly at describing it. I'm just gonna stop while I'm behind. Licensing screen, output log, company file, print manual, link to the license. Nope, seems pretty good. I've read a little bit on the license already. Godot versions, major, minor, patches, we call major, stable patches. Each stable branch starts with a major release without a zero. Okay. So this one's already out. Because I think, wait, are we Godot 4.4 or 4.5? 4.5, so it's already out. Which version should I use? Should I upgrade it? When's the next release? Don't care about that. Documentation changes. I don't care about these. Though I guess I can look really quickly at the first. I think I started with 4.2, so I can just check. Oh, that's probably a big one. Third-person camera with spring arm. Interesting. Yeah, I'm just gonna skip this. I don't care about the documentation changes because I am starting with all of the documentation right now in the current up-to-date version. Series will introduce you to Godot and give you an overview of the features. Following pages, you'll get answers to questions. Is Godot good for me? What can I do with it? Make the most of your time learning. Finally to the introduction. Gonna have a drink of liquid. Okay. Probably gonna fly through a lot of this still, because I doubt this is a beginner tutorial. What can the engine do? Oh, they're Argentinian. Didn't know that. Cool. Good for them. Started in 2001. Sheesh. Okay, so this is kind of the history of Godot. I mean, I might as well skim read it, because it's kind of interesting. Yep, just people that have made stuff with it. Ooh. That's I haven't seen that many, like, very realistic games made with Godot, so it's interesting that, some have been made. Planet Envertigung Skanonen Kommandant. Planet Interverdent Gungskonan Nen commandant. That is a word. P. Okay, so planet N. Planetin. And then KK. So that's the K. That's the K. Planet 10 vert. Planet 10. Vertig. Digungs. And then Canonin. Commandant. It's 4 words, but with no camel casing, just a whole run on. I wonder what language that is. Programming languages use their own syntax or C#, which is particularly popular. GD extension, high performance in C+ or other languages, yep. What do you need to know? A feature-packed engine with thousands of features, a lot to learn. Make the most of it, you need good programming foundations. I've got the foundations. Kind of. I haven't said the most, but I took a lot of AP coding classes in high school and got through a solid 1.5, I'm going to round it to 2 years of computer science in college before I dropped out because of stress and just overwhelmed. If you're entirely new to programming, don't need that. Oh, cool that they've got links to actual college classes, CS50. Free course, but I already should know everything that. Languages, don't be afraid of that. Yeah, I learned so many programming languages. In high school, we did Java and a little bit of Python. Specifically JavaScript, I should specify, because Java is separate. In college, I learned Python again, Java, not JavaScript, C++, and I could swear there was another one, but I can't remember the name. And I also learned a few machine languages, because at first in high school, I thought I was planning on being a, what is it, civil engineer, robotics engineer, whatever it is, but that quickly went by the wayside. Learn to code, you're not programming. Own your own browser with the GDScript app. To learn GDScript, you can use the app GDScript from zero. Ooh, that sounds nice. Can I close any of these? Tutorials and resources. Introduction, we're already past that. Multiple resolutions, we already have. One size fits all. Okay, this is into the manual. We'll get there eventually. Tutorials and resources. I'm just going to keep this here because it's going to be a good resource on my own time. Reflection probes. Okay. Well, I guess that's all I needed to see exactly what reflection probes were. Though I don't 100% trust the AI overview. Multiple resolutions. Scale. Okay. Canvas item. Stretch modes, which I closed the other one, so let's keep that there just to remember it's there. Might do this on my own. I don't know what the rules are on recording this. I guess it's open source. Okay, I've seen this website before. It's official, linked with Godot. Join GD School. Serious about becoming a game developer. I've actually gone through a few of the projects that they have here and messed around with some stuff that other people have posted. But we don't need this actively open. This app is an open source project. To report bugs or contribute, head to the code repository. Next part. Okay, user notes. Don't need to read those. I think I've tried reading through all of this documentation before and actually got sidetracked by this. Do I? What's here? Oh, this is all really beginner type stuff. I mean, I could just run through it. This is open source, so it should be fine for me to write. I guess it's good for learning the way that you program in the Godot base language. Yeah, it's probably good to run through it just so I know the formatting of the language. Learn program, telling the computer what to do, already know all of this. Computer needs exact instructions. Let's look at the formatting. Var. Okay, so you don't need to type your variables. You can just call them variable and then it auto types based on the value you give it, similar to Python. And then function works the same as Python. Ooh, it can auto type. What would this be? Instantiate. Would this be an object? Yeah, this is an object of some sort. And then there's a built-in function that adds a child node to the object that you just created in the script. Bullet global transform. What's global transform? Interesting. Okay, built-in function draw circle. Vector 2 is the way it's being rendered. 0, 0. Okay, I don't know exactly what this 0, 0 is, but I'm guessing 60 is going to be the radius. And built-in color function to it for aqua. Okay, so by default... File lessons, you'll learn how this code works. Follow the instructions. How do you give instructions to programming language? Okay. Rotato. Not a fan of this game, personally. Take damage amount. Okay, you can do minus equals shorthand. In some languages, can I open a notepad? Look at me being all fancy. What is this? Oh, a bunch of old things that I guess Notepad just remembered me having opened in it. So when it's saying health minus equals amount, it is getting the value of health. Let's say that health is equal to 5. You've got 5 health. Normally, if you wanted to tell the computer, hey, let's deal damage, you'd have to say health equals health minus 1. And then that would set health equal to whatever it is, but 1 less. But in some more recent programming languages, there has been a shorthand. So saying minus equals 1 would work. So health minus equals 1 is the exact same thing as saying health equals health minus 1. And this can work with other... depending on if it's implemented, it can work with other operations as well. So it's a lot easier to type this than to have to type out health twice and do the full thing. But obviously, if you're doing slightly more complicated operations like health equals health times 2, let's say health equals max health times 2 or health plus 50, obviously there isn't going to be shorthand for that. I'm just kind of pseudocoding here. Max means it's going to look at whatever's inside of the max and take the higher value. So it is going to run separately health times 2, so whatever this value is times 2, and separately whatever this value is plus 50. And then it's going to look, out of these two values, double bar typically denotes or in programming, so it's saying one of these two, one or the other, which one is higher, return that to be health. So like if health here is 20, then what that means is max of 20 times 2 or 20 plus 50. Which, if you evaluate that, it is a max of 40 or 70. So it would return the 70, and the health would get set to 70. But let's say you wanted to do, health is already set to, let's say 75. Then suddenly it would be 75 times 2, or 75 plus 50, which would get you 150 and 225. So suddenly, instead of the plus 50 being the higher one, it would be the times 2, and that would just automatically figure out which one of these two is better for the situation, give the one that gives more health. You could also do min, theoretically. I don't know what the notation for doing something like this would be in Godot engine, which is why we're here reading all of this. Okay, function takes damage. You can pass in variables to functions by putting them here. Okay. Health minus equals amount. If health is less than 0, run the function die, which would just be game over. What's the difference between this and Python? Nothing. Oh, they call it def instead of func. That would do it. Doesn't look that different, does it? Are programming languages all completely different? No, they're very similar. That's why college teaches you a lambasting of programming languages, because it's good to know the basics of a lot, because you never know what language you're going to be working in. Inventory, what you'll learn along the way will teach you how to move, how to handle an inventory. Mindset seen as a developer. Godot 4. Okay. Sample. Oh wait. Create a code sample free for the site. You don't need to change anything, just run it. Okay. Run into errors. Move already exists at line. Well, the compiler, the engine, doesn't give as friendly errors as this does. I'm here calling this a friendly error when they're like, well, this isn't the most friendly of errors. We can make it friendlier. But I learned very well from my first language being JavaScript. It has errors that are even more hard to parse than this. So I am pretty good at reading errors and figuring out what they're saying. Function move already exists in this class. So in this class is the whole page that you're on. There has already been defined a function named move, and then it's telling you what line of the program it's on. They're good, they're here to help. If you get an error, then that's a thing that means that if it didn't give you the error, you never would have known something was broken in the first place. This code is incorrect. It will cause an error when you try to run it. This code is wrong. My guess is there's no return statement, and Godot probably doesn't support empty functions. Most programming languages don't support empty functions. So would that be the syntax to return? Should use the return keyword. Okay, it's right there. But it's currently in a comment which the computer doesn't recognize. Oh, that should fix it. Don't need the brackets because return doesn't take an input. Interesting. Return doesn't take an input. Oh yeah, because they don't throw errors, so I guess return... But it's helpful to have return take an input, but I guess if I put return without an input, it would effectively be another empty function. Okay. Get a lot of the existing code. Calling a function, yep. Tell me about this run function run. Custom functions. Okay, this is just telling you how functions work. And yep, you tab to indent, so it's an indent-based SDK, not a parentheses like Java. Just code below do, select all that apply. Makes the entity visible. Well, yeah, it calls the function named show that makes this entity visible. I'm guessing. Is there a show code given to us? No, so I'm just gonna have to assume that. Well, it shouldn't be teleporting back up without more, but I get what it's shown here. How do you call a function? What is the syntax you use to call a function in general? You write the name, followed by parentheses, then a colon. Yep. Well, actually, colon is only for when you're defining it. Make the character visible. Ta-da! Make the robot upright. Rotate, and we're in radians. It's suggesting minus 0.5. Can just run this multiple times. Oh! Nope, needs to be positive. Let's make it positive 1 since it seems to... Ooh, that's too much. Oh, it probably reset the angle before it ran. I was thinking it was going to have a running what angle is it currently at. So I overcompensated. Drawing a rectangle. Oh, I remember doing all of this stuff in Java way back in high school. Move forward. Ooh, counts okay. So it's pixels and degree. Ugh. Why is it inconsistent? Why is some degrees and some radians? Turning left and right. Yep. You've got pre-made functions for it. And the function call below, which part is the argument? 30. The argument is what you put into it. Okay. Practice will make the turtle draw a corner. Move forward 200, turn right. Then you need to move forward 200 again. Oh, we need to put a amount it's turning, and this is in degrees. So it's gonna be 90 degrees. Oh, wait. Okay, we're moving forward, turning right 90 degrees, and moving forward. Okay. Ta-da! I added a extra line that didn't need to be there. Draw a rectangle, move forward 200, turn right 90, move forward, we'll do 100, since it's a rectangle, turn right 90, move forward 200 again, turn right, could use a function for this. That's gonna be shorter end, or wait, no, that's 90, it's a turn. then move forward 100, and that should be the full circle. I mean, rectangle. I know shapes. Length of 120. I asked for a length. I was just kind of going off of vibes. That should be the right size then. Yeah, there's the check here. I guess I should read that. Check, draw a rectangle of 220 by 260. Move forward. First two lines for you. Okay. Well, let's just, oh, copy and paste. Doesn't work here? No, it does. Let's fix that indentation. Okay, then we want to turn to 60. 260. Oh. 260. Is this the right? Draw a rectangle of... and that should bring us back to the beginning. Yep, should be taller than it is wide. Yep. I'm just doing this to get used to the syntax of the language. That this is all beneath me. I hate to say it that way. Calls the control forward, then turns it. Move and rotate functions consist of two instructions. Is this going to be... Yep, this is making a function to do this instead of typing it all out. Why do you use functions? To reuse code multiple times, put a name on multiple lines of... I mean, technically, but this wording is... Threading is what lets you run... I guess it's saying in one go, not at once. This wording just seems deceptive to people that know too much. Names and codes have rules. Yep. Underscore. Okay. Are valid function names. Can you use numbers? Can't begin with a number. You can't begin with a number, but you can use numbers afterwards. Can't have a space. That's fine. That's fine. This is camel case, because, well, it might be a slightly different name, but because every new word is capitalized to differentiate words, that's just a word, and this is underscores. But you can't have a space, or otherwise the engine, the processor, the editor, is that what the SDK is? We'll try to read its two different functions. Jump. Okay, jump moves it without drawing a line. Go to function named draw square. Should draw one square of length 200 pixels. Should take no parameters. Move forward and it's 200 pixels. And then it's turn right 90. And then we just literally copy and paste this. And get rid of the last turn, because it's unnecessary. And that's how it's going to segue into making a function, so you don't need to copy and paste that 4 times. Function, draw square, use it to draw 3 squares. You already created the draw square. So you need to create a function called draw 3 squares that will draw... if you call the function, all 3 squares should overlap. To stack them diagonally, call jump 300, 300 between 2 calls of draw square. To make this right... Oh, they put the turn right 90 at the end. I was going to say we're going to have an issue if there isn't a turn right 90 at the end. Func draw. I can type 3 squares. And then we're going to want to draw square. Doesn't need an input. Then it's saying jump. Takes 2 parameters. Probably positive x and positive y distance. Okay. We want to draw 3, don't need the jump at the end. Bump, jump, yep. Function, you can rotate, given an argument. How can I rotate in both directions? It can be positive or negative. Yep, did that incorrectly the first time. What's a function parameter? Number you put into the function to make calculations. A label you give to a value the function receives. This is a trick if you know more about what's going on, because you can give the parameter a name that labels what it is, but the parameter itself isn't the label, and it's not the name of a. I'm gonna stop talking now. Parameter is a label that represents a value. But we've just been using it strictly as it is the value, which means that that's kind of a weird way to phrase that. How do you create a function with parameters? See, now we've got the stand-in, what the actual ones are. Correct syntax. What is the correct syntax for a function definition? Function name. For the definition of a function starts with the func, then in parentheses name. No, it's right here. But I'm going to try to do this without it. Function name, parameter name, but it starts with func. So func, function name, in parentheses parameter name, but you need the colon at the end. Yep, you can, okay, uses comma and then a space to differentiate multiple. Parameters are optional. What's the correct syntax to define a function with multiple parameters? Okay, func space function name. Then in parentheses you want parameter. This one doesn't have commas. Lots of practice. Okay, before we create a rectangle of any size, let's see how we can use parameters to draw simpler shapes. Draw corners of varying lengths. Here we can use the function for 90 degrees. Draw corner, complete the draw corner function. So it uses the length parameter. Okay. Okay, draw corner, distance length. Okay. I see, they had hidden code that was going to run once you fill it in. So obviously the code that I wrote didn't do all of that, but they had some code running in the background that checked that I filled it in correctly. We'll improve our draw function so the angles can vary. Add the angle parameter. Angle. The draw corner. Angle. Now we can run that. Ta-da! On a function to draw a square of any size, func draws square. And then we're going to want the length as an input, and we're going to want to move forward length. Then we're going to want to turn right 90. I didn't copy that. I love hitting buttons. 1 length, 2 length, 1 more. 3 length, don't need the final. Yeah, let's call it at the end. It actually says here, be sure to turn right enough times. Turtle ends facing towards the right. Yep. So this one wants a proper full loop. Let's continue. Make our square more flexible. Should include rectangles. So now we need length, comma, width. So we'd want, height. Height is what is used for 2D. Duh. Length and height. So we're starting with length. If I could spell height, length, height. That should run. Yep. Take our first look at variables. Player score, keep track of a lot of things. Variables. Scale a character. Label used to keep track of a value that can change. Doesn't need to be a decimal number. Function, not a function. Variables with the dot. In rare games, you'll see many member variables that have sub-values. For example, position. Use coordinates x and y. So we've got position variable x, position variable y, meaning that position is kind of an object. Games, y-axis is positive going down. Yes, this is actually very consistent among a lot of engines and throws people off. Y-axis positive downwards. It's not like a XY graph that you see in math class. 1.5 times in size, scale, yep. Access subvariables. How do you access subvariables? Nope, you're right, the dot between, yep. I don't even know one that has you write an arrow between them. Okay. Position. Draw rectangle. The x position of 200 and the y position of okay, I read that backwards. The x position of 120 and the y position of 100. Draw a rectangle that is 200 by 120. These numbers, draw the correct one. So jump is local to the turtle, move this way, and setting X and Y is local to the whole screen, go to this spot. But they're similar besides that. Draw 3 squares of size 100 by 100 that are 100 pixels apart on the horizontal axis. Okay. Use the provided draw rectangle. Okay, draw rectangle should be 100, 100 from what we've done before. Then we need to jump. So it is going all the way back to where we start, which means we actually need to jump 200. And let's assume we're starting at x equals 0. And that means we need to add 200. Then we need to draw a rectangle again. But then we need to go to 400, and then we need to go to 600. First square should be drawn at 100, 100. These are 100 by 100. Okay, well, first shape at 100, 100. We can just put that in here and hope that it works. Change that to 100, 300, 500, 700. Weird how that bugged out before. I'm not sure what would have caused that. Error, the first square should be drawn at 100, 100. Okay. Theoretically, this is probably going to throw me an error, but theoretically there should be a way to, in a single line, set both the X and Y position. I'm not even going to try to guess at how to do that without knowing how the thing's set up. Theoretically, there's a way to combine these two lines into one, but I don't want to try to guess at it. Whew, this is going to go on for a while. Let's go back to reading for a little bit. That's a good way to do it. We'll break up the reading with some of that. And I'm going to get some more drink. I love drinking almost 100% of my daily added sugars. Okay, this I should actually read a little bit. Scenes, yep, I know how these work. They fill both role. Nodes are the different things that you attach to objects in scenes. Character body 2D, named player. Camera 2D, sprite 2D, and a collision shape. Okay. Trying to internalize this somehow, because this is showing the basic what you should put on a player that you're working with. Player, that should be easy to remember at least. Nope, game names end with 2D because it's a 2D scene, yep. Scene tree. Scene tree, that's just all of the objects that you've got in the given scene, which is at the top. Nodes emit signals when an event occurs. Okay. There's a lot of flexibility. Note signals are Godot's version of the observe pattern. You can read more here. Observer pattern. Oh, I meant to open that in a different tab. I knew there was a reason I was doing that by default. Unlock, fall off a bridge. Class. Okay. This is just basic setting flags. Signals are Godot's version of triggering flags. Okay. First look at the interface for a comprehensive breakdown. Go to the editor manual. My interface will probably look a little different because I've already done some stuff. Yep. Main area. Top edge, workspace. Yep. Scenes tab. We'll add new scenes. Oh, up here. Ah, I see. Interesting. 2D and 3D just get a little different. 5 main screens. Scene dock lists the scene's active nodes. There's no active nodes here. It's trying to get you to choose a node. So you choose this one if you're doing a 2D scene, this one for a 3D scene, and for UI. Wow, it literally says that if you read them. And then you can theoretically have the base scene be a different node. Sometimes, if you want to have like a persistent character inventory, you will actually make a character scene. So make the base node the character, and then call that base character scene into other scene nodes in order to have a more easily managed, consistent inventory. Just like some games will actually have the first scene that actually loads be nothing, and that scene will just have all of the flag management, all of the different memory allocations and stuff happen before actually taking you to the first screen. Sometimes this is done as a loading bar for smaller games, sometimes it's just a literal flash in the beginning of nothing until it loads. Read more, inspector, bottom panel, viewport is the debug information, 5 main screens. Asset library, 2D screens for all type of game, real builder interfaces, mesh with lights and level design for 3D games. Oh, that kind of looks like Deep Rock Galactic, if you squint. I don't think it is, but it kind of looks like it. Okay, bunch of examples. If you're running, you can go through your project, test it, pause and just say, this is testing. Any changes are not saved when the game stops running. Yep. It's a complete built-in code references. Finally, libraries, free and open source add-ons. Yep, that's add-on. Oh wait, asset library. I'm gonna need to look into that, because one of the things I've struggled with is assets. I use a lot of just default. I'm not the best at 3D modeling, and really not that good at 2D animation. Integrated classes. So eventually someday you're gonna see me going and having a stream where I just learn Blender. Just like how I'm doing all of this for Godot. You can search for information using the following methods. Okay, this is something to save. Do any of these window pops up? Yep, okay. Oh, and will take you to the corresponding page in the script main screen. Oh, that's nice. I gotta really remember this. F1 anywhere. Control click. Control click. I didn't get that on here. Let's just add that in case I actually end up using that. Double click an item to open the corresponding page. Yep. Alternatively, clicking while pressing Control on a name or function automatically pops that one up. Nice. That's good to know. I gotta remember to use that. Godot is a feature-rich engine. There's a lot to learn about it. This page explains how you can use the online manual, built-in code reference, and join online communities Making the most of this manual. It covers general features. To support online and offline. I downloaded the offline. Help. Okay. To browse online, head to the class reference section. All the way at the bottom. It tells you where the class exists in the hierarchy. Click on the shot point to jump to parent classes. Okay, so character body, body physics, collision object, node, canvas, node, object. So all objects are nodes. Wait, no. Summary of the class's role, can use cases. All nodes are objects, I think, is the correct way to read that. And all canvas items are nodes by default. I guess by default, theoretically, you could bypass having a hierarchy like that. Just telling you how to do that, learning to think like a programmer, I already kind of do. This is back to community stuff and community tutorials, already clicked that. How are we doing here? Step by step, your first games. Oh, we're actually getting pretty through it. Design philosophy, object-oriented. I know what object-oriented programming is. I've been saying object a lot. Yep. Character, wait, move, jump. And then you apply this character outline to the more specific versions. So Wizard gets all of this wait, move, jump. Warrior gets all of this wait, move, jump, but then has the special Wizard and Warrior things on top. Because all of these inherit being a character, but then get their special things on top of it. Tries, removed, etc. Open source. Yep, this is all stuff I've read before. Some of this likes to repeat itself. Feels like reading Homestuck at times. I see, I was at the end of introduction. Now we're at step by step. Make nodes. Following lessons are here to prepare you. Go the game from scratch. By the end of it, it'll be in depth. I'm gonna actually star this. Are there any favorited tabs that I can get rid of? We can cut you. I have no clue why you're there. Wow, cut isn't working. Cut used to work to get rid of bookmarks. Maybe it's a Firefox thing that's not how that goes. No, I wanted to finish watching those real bad. That's there for that reason. I like that. Don't need that. Okay. So now I can keep really important tabs here to look back to. Nodes and scenes. Let's go back to here for a little bit. Previous lesson. Predefined member variable name position. In your projects, you'll need to define your own variables. Mind that you need to track players' health. Keep track of that. You can make a variable named health, to which you add and subtract points. That's actually exactly what I did over here. We ignore that. Repellent bomb shows health variable. Okay. Storing health, value of 4. Defining a variable, var health. Can't define the same variable twice. Good to know. Most of the time you can't. Define variable. Access it by writing the variable's name. Print function works in Godot. Good to know. Why do they say uninitialized? Func run var health. It's a var keyword anymore once it to define a variable. So you define a variable, you can change its value any time with an equal sign. Yep. Why does it say... Oh, interesting. So that's like a live reading, but that doesn't seem too helpful. But the print function, actually this I should read. Option you learn academic programming courses. Yep, it automatically sends info. Use print to check value variables. Yep, it's used for debugging. And it's just print parentheses for a string. Put this as some text. Ooh, this is interesting to read. Variables are like labels. As we hinted above, work like labels, assuming the value of the same event, sticking onto something value. As a database of projection labels, all variables name a variable name attached to value. Let's run this. Okay, so variables in Godot are not aren't strict. When you make a variable, it is any type, or at least a fluid type, there's probably some way to make a strict typing for variables. That's something that's gonna need to be kept track of. Health variable. Okay. Do we need to make a function here? Did I spell health right? Yep. Okay. Didn't need a function for that. Once again, hitting code in the background to check what we're doing. Adding and subtracting. Yep, this is talking about the plus equals my... Hey, would you look at that? This is doing exactly what I was showing here. Wait, that's word for word what I was just about. Interesting. Okay, which increase health of the robot, select all that apply, plus equals health plus. Technically those other two could if the amount is negative, but we ignore that. Like it would be a double negative if you put in a negative heal amount. Theoretically, and I think a number of games do this, instead of having a separate heal function and damage function whenever a heal should happen, they simply apply a negative number to the damage function. Okay, what are we doing here? Amount of health when it gets hit should take damage. Start with 50, take 50 damage. Take damage amount. Add to the take damage function so it subtracts the amount from the predicted health variable. Okay. Health minus equals amount. And that should be it. The full health, heal, takes an amount, and should heal the amount. Oh, this is, well, technically, yeah, we could... This doesn't need to be its own function, but it will be. Amount, and then health plus equals amount. I wonder if the space is important here. I'm going to try it without the space to see if that's necessary. I didn't put func. Okay, the space isn't necessary. Interesting. I mean, it's good to do it just so that you can read stuff correctly. Fast take the process function. Oh no. Has functions that do certain actions. For example, show and hide function change the visibility of things. We can also create our own functions to make custom effects like adding or recovering health to a character. Godot also has special functions we can customize or add onto. Take the process function. This is giving me some flashbacks. I'm assuming process is a special function that runs every frame the game is running, and delta is a variable that you can put into it to augment how often certain things run. So delta, actually wait, no. Process, I think, updates every time the screen updates. It updates as quickly as the screen refreshes. Delta is a variable that is automatically passed into process functions that tells you how much time has passed between those screen refreshes. So the trick is you need to multiply whenever you're working with process functions like this. You need to multiply any movement variables or anything that could cause changes in the game by delta in order to avoid higher or lower frame rates changing how things run. Process gets its name because it does calculations on continuous actions. Just like a juice factory that processes juice bottles, the bottles are always moving along a conveyor while the machines operate on them. How many parameters does it take? It takes 1, delta. Do anything until we add something to it. Notice how the underscore is in front of the function name. This is used, I think it's used for any continually running functions. The underscore is precisely will automate every frame, and they italicized frame because of the exact reason I denoted before, that frames can be inconsistent. So they rotate that fast, but let's do something fancy I can do. Three, 4, 1, 2, 3. One, two. Huh. Oh, that doesn't get affected by it. They must have put either delta is somehow automatically being applied to this. Maybe rotate automatically takes into effect delta. That would be interesting. Well, that would make things easier. Because this didn't speed up or slow down like it should have. Did me doing that break anything? 0 frames dropped? I've never tried doing that while I've been recording, so I just wanted to make sure I didn't mess anything up. Yep, we're still going. Okay, good. For some reason, my computer has the option to freely toggle its refresh rate from 60 times per second to 240. So theoretically, that would affect frame rate. So I was trying to toggle the frame rate of my computer to see if this would visibly spin slower or faster. But it appears they have either the delta built into rotate, or they're secretly doing some things behind the scene here to make this go correctly. Times a second. Okay, this implies that it's built into rotate because we've switched from every frame for delta to a second for rotate. How often does this process run? Multiple times a second. And it seems like it's trying to kind of highlight and point out that. Make the robot rotate slowly, adding the process. Process is already there. Rotate. 05. Make the robot move in a large circle slowly by rotating it while simultaneously moving along its X direction. Rotate and move local X. So move local X is kind of like the jump. It's moving local to the robot, not to the screen itself. Put them in process. Rotate 0.05. Move local X. 5 pixels per frame. And that should make it do a large circle like it's asking. Oh, that's a smaller circle than expected. From process delta, rotate. Process function, almost everything in the game has a process function. Call image a frame, go that moves on to calculating the next frame. Sounds like a lot of frames per second. Often run at 60 FPS. Number varies. powerful computers get into hundreds or thousands of frames. What parameter does the process function take? Process function takes delta, it's right there. Frames take varying amounts of time to calculate. There we go. Now we're talking about delta. Function receives delta as a parameter. Delta represents the time difference. It's the time passed since the previous frame in seconds. We can use it to ensure that the changes between frames don't make the game's behavior unreliable. We ignore delta. If we ignore delta, the game's experience will vary depending on the computer. Delta makes the game consistent for everyone. The game took... How do we know about delta? What do we know about delta? It's the time it took Godot to complete the previous frame. Technically, yes. So value in seconds varies each frame. A lot of these are just click all to continue. The delta you get in process is time in different seconds. It'll generally be a tiny decimal number. To apply delta, you need to multiply your speed values by it. Yep. So this is where I was saying delta must have been either incorporated into the functions they had before, or they were doing some off-screen magic. It appears it is not incorporated into the functions, and they were just doing a little lie to make everything easier. Motion speed times delta, we're multiplying. Yep, multiplication. Okay. At the moment, rotation is frame dependent. Add delta to make the speed time dependent. Times delta. Easy. So we make robot move smooth in a circle. Okay, so this is just the rotate 2 times delta, and then move local x 100, and 100 would be right, which is clockwise, and then we need to do times delta. Did move local x not work? Okay, it did. Oh yeah, this is rotating about a spot behind it, not the center itself. Okay, let's go back to this for a little bit. Nodes and scenes. Let's create your first scene. Nodes are fundamental building blocks, camera, and much more. All nodes have a name, editable properties, receive an update every frame. You can extend them with new properties, and you can add them to another node as a child. The last characteristic is important. Together, nodes form a tree, which is a powerful feature to organize projects. Since different nodes have different functions, combining them produces more complex behavior. By taking a character body 2D, a sprite 2D, a camera 2D, and a collision shape, you make something complicated. So character body is the general character stuff. Sprite 2D is what it's going to look like. Camera makes it so that the camera follows the body, and collision shape makes it collide with the environment. Other node. Create new nodes. Yep, you can choose whatever of those you want. Select the label node. Click on the node. Create a button. Type text into it to make it say hello world. Interesting. So label is just like a 3D... Huh, interesting. Running the scene. The save scene as dialogue, like other dialogues in the game, only allows you to save files in the project. The res path at the top of the window represents project's root directory and stands for resource path. For more information, see file systems. Here's and invites you to select the main screen. Demo should run again moving forward. Every time you run the project, we'll use this scene as the select starting point. Okay. Next part, we'll discuss another key concept, creating instances of a scene. Okay, main scene. Test on scene, use the run current scene button. Another one's next to it, run project, allows you to set the main scene. Where is the run button? They changed how the buttons work. Or how they look. I should have noticed that before, so I actually need to figure out... Okay, so we're looking for that. Where is that? Oh, they're up here. Okay, so this is run scene, this is run whole project. Good to know. There are words for the feeling. See code nodes and sequences can be used. Previous part we saw a scene is a collection of nodes organized into a tree. You can split your project into a number of scenes. Help you break down and organize your game's different components. Create as many scenes as you'd like and save them as files with the T-scene extension, which stands for text scene, and the label scene. From previous section we call these packed scenes as they pack information about your scene's content. Composed of a 2D body, allows the ball to bounce off and on walls. Yes, I stepped through and did a little programming thing like this ages ago. I think it's been deleted from my projects folder at this point. Pop-up that appears, project.godot, click import, and you can put balls down, spawn them different areas. You can click over here on the side and affect the properties of the balls, make them bouncier, heavier, all sorts of things. Change the properties of one ball without affecting others in the inspector. Change the default properties of every ball using the ball... It's way up here. The base ball, the parent ball information, ball T-scene. There, make all of the values update. Double click that. Shows the dock on the left. You can update it, press enter, make it more or less bouncy. Notice you are unable to change the values of physical material of the ball. This is because physical material is a resource and needs to be made unique before you can edit in a scene that is linking it to its original scene. To make a resource unique for one instance, right-click the physical material property in the inspector and click Make Unique. Interesting. Scene instance as a design language. Shooter game like this. Are we reading from the top or the bottom? Technically we're market HUD stage. So everything is part of a stage. These connect both ways. With the diagram, at least for almost any game, each rectangle represents an entity that's visible in the game from the player's perspective. Arrows point towards the instantiator of each scene. Once you have a diagram, we recommend creating a scene for each element, listed in it to develop your game. You'll use instancing either by code or directly in the editor to build off your tree of scenes. Okay. So I knew about making different scenes for each object that was going to be used. But I didn't realize use it for literally every single object. Interesting. So you'd even want... Okay, it makes sense though, thinking about it, that does make sense. because it's easier just to have a separate unique page for each of these than to try to copy and paste them from each scene to another pretty much. Programmers tend to spend a lot of time designing abstract architectures and trying to fit components into it. Designing based on scenes makes development faster and more straightforward, allowing you to focus on the game logic itself, because most game components and maps link directly to a scene. Using a design based on the scene initiates means you'll need little other architecture to your code. Here's the example of a scene diagram for an open world game where tons of assets are nested elements. Okay. This table, chair. So room in a house. House can have a room or a door. House can be part of a citadel, but a citadel also has a church, and the church has seats. And the terrain can be the citadel's city, can be the bridge, which has guards. And for some reason, the terrain also houses the player in the HUD. Room, we could make a couple of different room scenes with unique arrangements of furniture in them. There we could make a house scene that uses multiple room instances for the interior. Create a citadel of many instances of houses and a large terrain on which we could place the citadel. Each of these would be a scene instancing one or more sub-scenes. Okay, this makes sense. I think I stopped before when I started doing this years ago when I first went through. I think this is all new stuff for me that I'm reading, because I knew about instancing things ahead of time, but not to this extent, so this is all very useful to recognize. Entered all over the game world, yep. So that is good, and we're going to take another coding break. This lesson will make our code easier to follow and understand, like lints, function, process, delta, rotate, 4 times 7. What does number 4 mean? That is 4 degrees. I mean, it's technically how fast the character rotates. Because the higher that number is, the faster they'll rotate. And this is rotate, it's not movement, so I think it is rotate, not amount of pixels. Looking at the function name, so it's hard to recall what number was. Looking at the code, we've seen how different functions have different names. So we learned this name, we can call these variables. Variable will name a value, what 4 does, angular speed times delta, yep. And then pull which line defines the angular speed variable. Var angular speed equals 4. New angular speed equals new angular speed. Yep, we can also define variables inside of functions. But if you define a variable inside a function, it won't exist outside of the function, so you gotta be careful about that. The identifier angular speed isn't declared in the current line at line 6, because you can't use variables declared in other functions because they aren't script-wide. Where can we define variables? Outside of functions, inside of functions. Variables are also great at grouping values that control how characters behave. Grouping them in this way allows us to easily change them. Yep. Okay, let's get 4 here. So we know what it does. Create a variable called angular speed outside of the function. Equals 4. And we can do angular speed and run. Something wrong with the code here. Can you see what it is? Function process delta var angular speed equals 4. So we're setting it there. Rotate angular speed times delta. Delta's here. New angular speed. This should be set outside of the function, not inside of it, because it's being called. Right here it's trying to call angular speed, but when it's set inside of the function, it's a local variable instead of global. So it needs to be set outside, so it's a global variable. If only it were that simple. Previous lessons, but there's no limit to how much health we could have. Player could gain health infinitely. What happens when we damage our character? Suppose our arms take 25 damage to times would be negative 25, which is not good. Which is why we have to put a bars on how far and low it can go. 7. Oh, we're getting into if statements. That's how you're doing it. Which one of these is true? This 1 is not equal to 3. 3 is greater than 1. 3 is not less than 1. 2 does not equal 1. 2 is less than 3. I know how if works. This series of if statements is all wrong. Change the comparisons so the comparisons match the instructions. If health is greater than 5, that is less than. If 1 is less than health, you just flipped it. If health is equal to health, well, health should always be equal to health. If health is not equal to 7, health, exclamation point generally means not. So anytime you see a exclamation point in programming, unless you're doing like mathematical factorio, you can almost just always replace it by saying not. So health not equals 7. Health is not equal to 7. Some languages need a double equals to do a comparison, because this isn't saying set health equal to health. It is saying is health equivalent to health, which the double equal sign, instead of assigning a variable, is a comparison, just like greater than, less than, not equal to is a comparison instead of a, what's the word, assignment? Okay, have a heal function, adds amount to the character's health, is never, make sure that the character's health is never greater than 80. So after health plus equals amount, then we're going to say if health is greater than 80, health equals 80. So if the health ever goes above 80, set it equal to 80. I don't know if I need parentheses here. Let's run it with parentheses just to check. So that is setting an upper bar to how high the health can go. Preventing health from going below 0. Take damage amounts. Health minus equals amount if health less than 0, health equals 0. Do we need the parentheses? We do not need the parentheses. Since the first language I learned was JavaScript, I am used to needing parentheses everywhere, so I, out of habit, place a lot of parentheses in stuff that don't need parentheses. Thankfully, most languages just let the parentheses be there and don't care. 0 and 100, strength and toughness, you can set that by having levels. This is linear. So that's linear. This is exponential. So we would multiply the health to make it. What is the value of damage? Power, calculate damage. Damage equals power times level, it would be 15. Times equal in the same way as minus 1. Yep. What's the value of damage now? Damage equals power times level. 15 times 2 is 30. Exponential growth to max health. Max health has the ability for it to make it extra tough at higher levels. Okay. Make the robot stronger when it levels up. Add to the level up function. Increases level by 1. Plus equals 1. Increase max health by 10%. Max health times equals 1.1, because it is itself plus 10%. Robots level 3 or more will want to take a lot less damage. Add to the take damage function, so the following happens. If the robot's level is greater than 2, reduce the damage amount by 50%. If the robot is level 3, that means they will attack for 10 damage, it should reduce it to 5. That seems a bit severe, but let's see here. Take damage amount, health minus equals amount. Okay, what's the efficient way to do this? There are multiple ways to do it, but what's the efficient way to do it? We'd probably start with the if. No, let's just do it. If level greater than equal to 3, I guess we can just do greater than 2 instead of greater than equal then. Greater than equal to. If level is greater than 2, health plus equals amount times 0.5. What could be wrong with this? If greater than that, it heals back the amount. If there was other reductions due to, say, a shield or something, this could get funky, but that's outside of the scope of what we're currently doing. Oh, there is something weird that could have happened with that, but probably fine. Okay, scale. So far you've come across 2 variables in the course, which are vectors. Which are they? That would be position. We haven't done anything with speed, really. Well, I mean, technically we have. Scale is scale a vector? Okay, I guess it is a vector, kind of. Oh yeah, because it has an x and y component. So yeah, it's scale. Look at this guy following my mouse. Woo. Oh, they made it so it follows when the mouse is off the screen. It used to be if the mouse was out of this little box it's in, it would stop moving. Now we scale the robot again, this time by adding vector to it using vector 2. Okay, that's the... Remember how I was saying before there's probably a way to condense the 2 different lines into a single one? This is the way to write when I want to condense it into a single one. Vector 2, or scale, since it's being labeled edit, plus equals, add the full vector to it of both x and y. Okay. Remove the recessive 50 pixels to the left. So you would subtract a positive x vector. You wouldn't need to declare x since you're subtracting a whole vector. Okay. Allowing code to level up function to increase the scale of the robot by 0.2 every time it levels up. We're just assuming that these things have already been declared. Vector 2, I believe specifically, is a 2-dimensional vector, which is why it's 2. So theoretically there would be a vector 3 if we're working with a three-dimensional vector, and there is theoretically a vector 1, which is a one-dimensional vector, we don't worry about that. Vector, and we want to multiply this. Or wait, is it add or multiply? Increase the scale every time it levels up. I believe it's asking for us to add. Oh, wrong number. Now, was it add or multiply? Okay, it was add. Robot's level has increased a lot, so is its size. Let's fix this by resetting the scale in positions. Func reset robot. That sets scale in position. Scale equals vector 2 1 1. Position should be 0 0. 0, 0. That should work. This is questionable, but it should work. Okay. You'll learn loops. Loops. Now let's go back to reading a little bit. This one will give you an overview of the available scripting languages in Godot, on the pros and cons of each. I already know the pros and cons pretty much. Files a ship, the camera's 2D node. So by default, imagine you want the camera to shake when the player takes damage. This feature is not built into Godot. You'd attach a script to the camera node and code the shake. Available scripting languages. GD script, C#, and via extension C and C++. Provide flexibility. Which language should I use? Beginner should use GD script. Provides tightest Godot integration. For C#, you'll need an external editor, which I don't think I have it on this computer. I had one on my old laptop. Is now mature. You can find for learning services for it compared to GD script, which is why we recommend C# mainly to users who have experience with the language. GD script, yep. Dynamic type, I should read this. Simple syntax, that's fine. Blazing fast, that's just bragging. Tight interior integration. Okay, built-in vector transform types, yep, this is nice. Making efficient for heavy use of linear algebra. This is just kind of how we could add vectors directly to each other in that previous example. Support multiple threads for as efficiently and statically typed languages. Support multiple threads as efficiently as statically typed languages. Interesting. No garbage collection. Gets in the way when creating games. The engine counts references and manages the memory for you. In most cases by default. Okay, it's just saying you don't need to allocate stuff and then clear the memory after it's been unallocated. Gradual typing. Variables have dynamic types by default, which is why I'm saying you don't need to type your variables. You can also use type hints for strong typing checks. I'm actually just going to read this real quick. Hi, Wikipedia. Will soon be over, but we're not sure about. We'll have access how many times it's just knowledge and finds will be in a few hours after nearly 25 years. Promise. Created people, not by machines. It's not perfect. Less than 2% of readers donate. So if you've given the past, donate today. If you're undecided, remember contribution helps. I have donated to that before. System stat line typing, dynamic typing, some various system steps, typing, history, implementation, extract known data types, examples. C, Perl, programming, languages, C#, Objective-C, CSS. Huh. GDScript looks like Python. Yep, I've already pointed that out. You structure your code using blocks and indentations, but it doesn't work the same way in practice. It's inspired by multiple languages, including Squirrel, Lua, and Python. I've not heard of Squirrel, actually. I've heard of Lua. I don't use Python or Lua directly. Years ago, was both built on both. Took a lot of work and had limitations. For example, no threading support, multi-threading was a big challenge with Python. Developing a dedicated language didn't use us more work than intelligence and output need. Net C, net version, scripts, play logic, attention. C# you can go not fork and output can be a web platform. Okay, already read that. It's been a few places. C++ extension. Those are the things you gotta include for extending C++. Scripts are files containing code that attach nodes. Okay. I feel like I've done this before too. Or maybe I just feel like I've done that because it's what we've done here. Node, animated sprite, sprite 2D, default texture, attach a script to the object. Should appear with your sprite 2D, open a file. The following line of code. Every GDScript file is implicitly a class. The extends keyword defines class script inheritance, or extends, in this case script sprite 2D, meaning that our script will get access to all the properties and functions of the sprite 2D. Okay. Canvas node. GScript extends keyword, you'll implicitly extend the ref counted, which is used to manage your application's memory. Oof. Inherited properties include the ones you can use in the spectre clock, like in textures. In the spectral title case underscore, you can hover over any name, get identifiers, hello world, print hello world, sprite 2D screen, delete the initialize, save the screen as sprite 2D screen. If you haven't already pressed to run it, look at the output bounds and say hello world. Yep. Delete the init function, so you're only left with the line extend sprite 2D. Time to make your mode move. Following after extend sprite 2D line. Angular speed equals pi. Extends line, angular speed. Ah, this isn't taking any delta. We can use the process function node. Oh, there it is. Implement delta. Wait, let's read this. To move our icon into up position every time the frame loops, we can use the process virtual function of the node class. If you define it in any class that extends the node class, like sprite 2D, Godot will call the function every frame and pass as an argument named delta. There we go, now it's adding delta. Okay, we already pretty much did this. Yep, this is just putting everything we did together. Sprite 2D, defining these variables for it, making the process function. Speed times delta, yep, that's there. Velocity equals, ooh, we're getting velocity. Vector 2 up, rotated, rotation times speed. Vector 2 up, rotated. Vector 2 up is a vector pointing towards forward for our relative icon. Oh, so up on the icon, is there an image of the icon, is this way. So the way that it's moving with that vector 2 up is it's constantly moving in the direction of that vector is what they're doing. Okay, so they're making all of its movement into one line instead of multiple ones. They're calculating what the rotation should be, and then making a velocity which is the upwards direction times the speed and rotated an amount equal to what was already calculated. So each update, it's rotating, moving forward the amount it should. And that's all being called velocity. And then you're calculating position based on that. Okay, I see. I was a little confused by that note at first. So, okay, another important feature of any game, being able to player control. Yep. Need to modify our sprite 2D. I think I've done this before, which makes it weird that I didn't remember one of those in-between pages. Unhandled input. Maybe I should be following along with this. Oh, let's go to this for now. Oh, cells. Ugh. General. Using while loops to repeat code. You can use a while loop to make a computer repeat a block of code, including a specific condition or decide to break. Here's always use a while loop. Yep. While using a variable number, keep track of how many loops it has. Go through a while loop. We have 1 to a number. Yep. But where's our more complicated while and for loops? While cell x is less than border size x, subtract 1. While loops can cause issues. What is the issue here? Move to end while cell x is less than board size dot x minus 1. Cell x plus equals 1. So why did it move down 1? Oh, it was always down 1. What would happen if a computer tried to run the code above var number equals 0 while number is less than 10, draw a square? It would draw infinite squares because you never told this number to go higher, so this number will always implicitly be less than 10. Okay, function move to bottom. Robot has decided to stand at the top of the board. Complete the move to bottom function. So it moves to the bottom. Board size is determined by the vector 2 board size. So it was 2, 0. Okay, we're starting at 0. Move to bottom. While board size, get the y from it. Positive as it goes down. So right now we're at 0y, 1, 2, 3, and forward. So well, the board size is full y is less than, no, greater than. What would our current location be? How would I call our current robot's location? Are we just assuming the robot is always starting at the top? We can skip a little bit if we assume the robot always starts at the top. Well, vector. Okay, I need to think for a second here. Assuming it's always at the top, so we just need to... So we need to initiate a variable for the while statement. Var location equals 0 while lock is less than, and it's starting at 0, so we can, so it needs to be less than equal to, I believe. This might overstep the amount that it needs to go by 1. Less than equal to board size y. We are going to how do we remove 1 from our location? Moves on the bottom of the board. Vector 2 and board size. By the vector 2 board size, robot's current cell is vector 2. See, my thing is, I don't remember what the way to call the robot's location is. So we've got a loop here that will run until the robot reaches the bottom of the board, but I don't remember how to move it down the board, which is what I'm going to take this for. Y subvalue of a cell. Cell.y. Okay. Y plus equals 1. Does that work? Nope. Do I need double L? We're adding 1. Well, location starting at 0 is less than board size, which should be a positive number, specifically for the Y coordinate on it. Oh, there's stuff here. I see. Stores how many cells make up the board, size X, and height. Vector 2 cell, default, vector 0, 0. Okay. Okay, I can work with this. Okay. Wow, we don't need the location variable. While I didn't realize there was documentation down here. Cell dot y is less than equal to board size dot y less than equal to, no, we don't want the equal to, we just want the less than. Cell dot y minus equals 1? No, plus equals 1. Is that what I did wrong before? Did I put minus equals? Less than... No, we do want the equals to. Whoops. We don't want the equals to... Wait. Okay, this isn't starting at 0. That's my issue, so we actually want minus 1. So we didn't want the equals to, which is what I said, but I was assuming board size started at 0 instead of 1. That's what my issue was. While loops. Because it never increments the number. Yep. For loop will look. Listen, for loops don't run infinitely. You have to declare how long they'll run. Ooh, range function. Been ages since I've used you. Range 3. Okay. For blank in blank. For X and Y. That's the formatting. Just like Python. Would range 6 create range 6. Okay, creates a list of numbers from 0 to n minus 1, which means we go from 0 to 5. Okay, it's just like Python. Starts at 0, runs to 1 before. Yep, 0, 1, 2. And this would run the same thing, because you don't need to put a range into your for. Var element equals array 0. That should just print 0, 1, 2. for loop instead of a while loop. Also, for number in range, board size x minus 1, cell plus equals 1. Okay. Move to bottom, use a for loop for... what should we call it? For steps in... let's look at this. Range should be 0. Oh, we just put the length. Which means we would want the board size y. For steps in board size y, cell y minus equals 1 plus equals 1. And that's also still assuming that we start at the top. Minus 1. That's one of the things that changes a lot between languages. How those stray numbers are handled. Run jaw rectangle for a for loop. Duplicate the code in the run function. The turtle and run rectangles. With our new knowledge of for loops, we can condense this code to take up less space and make it easier to modify. To draw 3 squares in a horizontal line. Okay. For squares in range 3. Let's just do we want to start with the jump or end with the jump? It technically isn't explained in this description. So this should be 3 squares. And we're starting with the jump instead of ending with it. We'll see if that throws an error. It doesn't. Okay. Normally you'd expect to end with the jump rather than starting with it. The range function we saw in the previous lesson outputs lists of numbers. This is a value, so we can call an array. Yep, that's an array. Step by step to see how it works. Yep, we already saw all of this. Syntax for values. Yep, that's an array of vectors. Using an array to fire a path. Numbers, elements, and vector 2 points map, make turtle pet. Wants to follow the robot. There are rocks in the way, having to tell the rock with an array. Vector 2 represents the turtle needs to walk through. Okay. So player inventories or design attack combos. For now, let's practice arrays. Okay. Fill in the turtle path with vector 2 coordinates. Okay. Let's actually highlight that. We'll need to move 1, 2, 3, 4, 5, 6, 7, 8 times in order to get there. So we need to move to 1, 0, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 5, 2, 5, 3. 2 coordinates, to avoid the obstacles. These are vector 2 coordinates. Do I need spaces? Oop. Fire turtle path. Okay, what am I doing wrong? Do I need to have the vector 2 in front? This is what non-strict typing gets you. If this had more stricter types, then you could assume that all of these are vector 2's for this variable. But this is not a strictly typed language, so we need to specify each one of these is a vector 2. Ugh. That's cumbersome. Okay, in this tactical game, the player and computer can select multiple units at once. You need to call the select units function, pass an array of vector 2 coordinates to know which units to select. Each vector 2 in the array tells the select a unit. So you select all the units on the board by pressing select units. Select units. Pass an array of vector 2's. Vector 2 with our room for variables, comma, bum, bum, bum. There's all of them. We have got 1, 0. We have got 5, 1. We have got 4, 2, and 0, 3. Yep, that should be it. Dun, 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 dun. Range, combination for for loops. Range, print number, yep, I know all of that. All this code print var numbers 0, 1, 2, 3, 4 numbers. Print numbers will print 0, 1, 2. Walk with the loop. Move path, for cell in path. Turtle move to cell. For each coordinate array, same cell, there's this new cell, so if we select and array together, for cell in cells, if cell in unit, select unit append. Okay, we're doing some fancy stuff now. Kind of fancy. In the array, if cells in units. Okay, we've got units. Okay, so those are predetermined. Let's look at the documentation. REI pathfinding. I'll provide a path for the robot to move at the edge of the grid. Your task is to use a for loop to make the robot move. To move the robot, call its move to function, like so. Function robot move to. Move to function only exists on the robot, which is why you need to access it this way. And then we need to pass it a vector 2. So what we want to do here is for step in robot path move to step. And we're just hoping that all of the steps in robot path are in the correct order. Want to draw many rectangles, something surprisingly common in games. However, writing this code by hand can get tedious. Instead, you could draw the size of your shapes in arrays and use a loop to draw them in batches. Use a for loop to draw every rectangle in the rectangle sizes array with the draw rectangle function. Okay. For so we've got, yep, we've got the draw rectangle function. And it's a vector 2, so we can just pass it that directly. Rectangle in rectangle sizes. Draw rectangle rectangle. And then do we need to put in the jump ourselves? Rectangle too few arguments. Do we have to specify x comma rectangle dot y? Does it need us to specify that? It does. And it does not have the jump, but I can't stop this early. So now we need to do jump then how far do we want them to jump? Okay, let's make it jump the rectangle dot x plus 100 and then 0. So it's jumping 100 units further than the x dimension of the previous rectangle, which should make sure it never overlaps. Of course, we've mostly stored numbers and variables. Let's go back to reading a little bit. Built-in callbacks, mainly unhandled input. This isn't where we were. Listening to player input. On previous lesson, building your first script. Another important feature of any game, giving control to the player. To add this, we need to... Let's actually... Convections. Create a new project. Okay. Let's actually open this. This is... just gonna remove it because it's been so long since I've worked on a lot of these. You may think, oh my, you're deleting huge projects. No, these were like single scenes that I was just fudging about in. This might be my older version of this, actually. And this was me figuring out instancing before. Is this, Oh, let's just remove it. I think that's the old version that I did. Source project follow along. We're doing forward. Do a new project, other node. And sprite 2D. Other nodes, right 2D. There we go. Since you only have that, sprite 2D node represents the texture. It says empty. To display the Godot icon, click and drag the file icon.svg from the file dock to the texture slot. from the icon to the texture. There we go. Click and drag to center it. Yep. Description, glitch attack script. Let's just go. So we're attaching it directly to this sprite. So we can add a new script. Does it want us to give it a specific name? Check the script's language. Guess the name doesn't matter. I've already got the language configured. No default to object empty to start with. The attached node script window appears. Allows for you to select the script's language and file path. Change the template from no default to object empty to start with a clean file. Leave the other options set to their default values. Click the create button to create the script. Well, this isn't empty. New script. Inherits. Shouldn't be inheriting anything. No default object empty. No default object empty. I'm not seeing any of that here, unfortunately. Template, okay. Empty. Okay. Don't save. I just deleted the... Whoops, that's not what I meant to do. Scene. Add other nodes. Sprite 2D. Let's go back to... Don't say... I see. I thought that this tab here was for all of this. Let's... close. Other nodes, Sprite 2D. We can delete that, remove, put this back here, go back to our 2D view, get you in the middle, add the script, make sure it's empty, object empty, there we go. That probably looks better. Implicitly a class, extends keyword. Want to admit the extends, yep, we already read that. Hello world. Function initiation. Only doesn't do anything, let's just make it print hello world. Func init. Print hello. I've started doing that, and I don't know why. I've started putting a W at the end of hello. And I know that I'm typing hello world, so it makes sense I'd be typing an W afterwards, but I've just kind of started doing that in general, which, oh boy. The script, break down the func, defines new initiation, defines function. Init runs every time the scene is initialized. So if we made another scene that we inherited this particular sprite 2D to, anytime we loaded the sprite 2D or a copy of it into the scene, it would be initialized and print hello world. But this scene is just the sprite, which means when we locally run it, we should get the message. Huh. No message. Oh no, there it is. It didn't run properly. Hello world. Extend sprite 2D, delete the init function. So we're just back to the sprite 2D. Because we don't want things to run on that. What is this? I remember reading about this. Oh well. Make it extend sprite 2D to send it census var. Okay, we're just doing var speed equals 400, and then it wants what? Var angular speed equals pi. Oh, that's just a built-in ability, pi. So we've got like some .math extensions here. Angular speed. Can use the process. Yep, underscore process. Func. Let's put another enter here. Underscore process. Let's, for simplicity, just make it delta. Not do all that extra stuff. Why is it red? Expected indented block after function. Oh, because we don't have a pass. Node class, if you define it. Class extends the node class, like sprite2d time. Pass sends the frame. Process delta, rotation plus equals angular speed times delta. Sorry, I need to read that one more time. Rotation, but this isn't a defined var. Rotation equals angular speed times delta. Angular speed times delta. Then what else are we doing? Do we define rotation, or is rotation built in? Did I miss something? Our angular speed delta. So it's a function of the node class. Sprite 2D pass delta. Bottom of the script define the function process rotation plus equals. Okay, it seems rotation is a built-in value, so we're just adding to what it already is. Okay, and then that it's saying should just make it spin? Yep. Okay. Good, good. Turn in place. Moving it forward. Okay, vector 2 up. So up from it. Up from object position. Vector 2 rotation. Okay, so up is direction modified by the rotation times the amount of speed for the velocity. Okay. I am just going to copy and paste this one actually, but I think I understand it. Oh, it doesn't like that. not indented. Z equals vector 2 up direction times speed. Okay, it's not rotating. Did I need to keep that? Rotation. I did. It calls on rotation. Okay. Let's go back to the script. Okay. So rotation is angular speed times delta. It's making the velocity. Velocity is equal to up from the object's vector. Okay, so velocity is a vector. And it's getting up from that? Up unit vector, y is down in 2D. So this vector points to negative y. Okay, so it's giving vector up, so direction upwards. From that, rotate an amount equal to the rotation, which is taken in delta as a factor. And then whatever that vector ends up being, multiply it by speed to get your velocity. Why are we taking into account delta twice? Something feels wrong that delta's here twice. Drawing the new lines are done the same way. We saw a var defines a variable. So it's into vector 2. Yep, that's pretty much what we've got. Okay, creating your first script. Let's move back to here for now. What are strings? Yep, strings, parentheses. Name is robot. For character in robot, so it's going to print out R-O-B-O-T. Yep. Which of these are strings? Select all that apply. Those two are. Technically, the one solo could be a string, depending on how the loose assignment of variables works. Or at least it could function as a string effectively. Only robot number has a store in the robot name variable. Change the robot name variable so that's a string instead. You can give it any name you'd want. You're literally asking me to name a random Godot character, and I'm blanking on being able to come up with names. Sure. Yeah. Following animation names. This practice will chain together animations using an array of strings. You might find such combinations in fighting games. Robot has the following animation names: jab, uppercut. Populate the combo array with animation names as strings. Ta-da! Oh. For loop, I see. You want me to make a for loop. Oh, and play animation. There's a lot more going on here than I thought. names of strings. Then for each action in the array, call the playAnimation function. What is the playAnimation function? Animation name. Okay, so for action in combo play animation action. And that should be what we need. Whoops. There we go. Functions that return a value. Until now, functions make calculations and return new values, yet built-in functions that return a value. Round. So round is a function that automatically returns the rounded form of it. .math. This is rounding the health. Lerp. Linear interpolation, yep. Turns a weighted average between two values, which makes the turtle move faster the further away the mouse is. This function let me add cells to cell. Divides vector 2, function convert world coordinates cell, return cell. Divide by 2, that's just giving the area, return keyword. Returns the value to the coded function, so receive the result where you call the function. Yep. Convert world to coordinate cell. Define a function that converts the position on a grid to the screen. The function takes in a vector 2 cell coordinate as an argument, and it should return the corresponding vector 2 screen coordinate at the center of the cell. Okay, cell size is 80 by 80. So we're getting a vector 2 starting at 0, 0. And are we aiming for the center of the cell? What part of the cell are we aiming for? Because if the cell size is 80 by 80, the center of it would be 40, 40. So we'd have to add 40, 40 to every vector. Convert world coordinates to cell. And I'm assuming we're starting at 0, 0 with world coordinates, which would actually just mean we can take cell, which is world coordinate that's being given, times cell size plus vector 2 40 40, and then we can return all of this. And I'm gonna, force of habit, put it in parentheses. This is sloppy. I should do it in 2 lines to make it clearer what's happening. Hey, I was right. I did have to add the 40, 40 to each one. So this is taking the vector that is being given. So this would be 0, 1. It's multiplying it by 80 in every field, so 0, 1 becomes 0, 80. But 0, 80 is right here, so I add 40, 40 to it to move the point to the very center of the square. How do I move on now? Continue. Pending and popping values. Yep, I know how that works. Pending, popping, how do you keep track of things in an array? When it comes to meal, append to the array. Notice how we call some functions by writing a dot after the variable name. like a given value type can have subvariables, can have its own functions. Okay, 2 arrays, a meal name, writing orders dot append. Okay, so we're taking the array and appending meal name, complete current order, first order equals waiting orders, pop front, completed orders, append first order. Okay, I see what you're doing there. Whenever someone orders a meal, put on the end of the array the name of the meal. Whenever the first order in the array is completed, take the order from the front, pop stores the variable, so it's making first order actually equal whatever the first order is while removing it from the array, and then appending to a separate one completed orders what the first order was. Firing a dot after the name, append, pop front, write out append, queue orders, waiting orders, add order, meal name, append meal name. Okay, we can use string to represent a meal, add orders, cheese sandwich, other functions, waiting orders, array is called pop front function. This pop returns the order, which allows us to assign it to a temporary variable. Yep, that's what pop does. Instead of, there are other options besides pop, but I can't think of the word for it. We call arrays like waiting orders queue. It's the first one we remove. Call arrays waiting orders. What does blank mean in arrays as stacks? Take a factory management game where you need to retrieve materials from stacks of crates. They arrive in the factory piled up vertically, and you take them from the top to the bottom. Take a crate from the back of the array, we do pop.back. This function removes pop, returns it to you, value arrays, to demonstrate how the array gets smaller. Pop front returns the value removed. You'll often use it to store value in a variable. The variable in question could be the crate's contents, which you can then use to give the player resources. And the following uses, you will use the append.popFront and popBack array functions. Okay. The waiting orders array will be filled over time. Your job is to move orders from the waiting list to the completed orders list using the array's append and pop functions. Remember that the array's popFront function returns the value, which skips a few steps. Okay. So we're assuming we've already got stuff, which means that we are going to do 4... Wait, do we want to do 4? Waiting orders will be filled over time. Your job is to move orders from the waiting list to the completed orders by using append and pop front. Okay, completed current order, so that means waiting orders dot pop front finished. Let's make this var finished order equals waiting orders pop front. We can do this all in one line. We can do this in one line without a variable. It's just cleaner with a variable, but I don't like how it's condensing, so let's just do it all in one anyways. Completed orders dot append. Or are we doing append? Yes, we are doing append. That should be the correct syntax, and we don't need to return anything because these are affecting variables outside of the function, global variables. Can't assign to an expression. We need to put this inside of here. Okay, what is the proper syntax for this? Okay, so a completed order. Your job is to move orders from the waiting list, complete order list by using the arrays append and pop front functions. Remember that the array's pop front function returns the popped value, which allows you to store it in a variable and then pass it to another function. So we want to completed orders dot append. So add to that waiting orders dot pop front, and pop front shouldn't need something put into it. Complete. I love spelling. Ugh, I think I probably just had a spelling mistake somewhere in the first run of it. Those probably aren't supposed to overlap like that. Crates are piling up on the platform, move them out of the way by popping them. From the crates array, you need to move them back. Move them from the top to the bottom using the array's pop back function. Your code should move all crates in the array while using a while loop. Careful if you run a while loop carelessly, you can lock the software, you can check. Crates still can't spell out well crates. Okay. Well crates. I see. Okay, so while crates has any values in it, this is gonna run, is what this is saying. Well crates. And then what are we doing once we pop things off of the back? Just pop back. It's not saying we should return them or anything. That's not the right syntax. Crates dot pop back. And we just aren't. Okay. Okay. Didn't want us to return anything. I guess it is still affecting the crates since they're global in scope and it's local. For value in array, print value. 10th item, there's a dedicated notation to end access numbers in array. Yep. 3. How do you access the third item in an array? Because it starts at 0. How do you access the third to last item in an array? Oh, this is something interesting. We can use negative indices. If you write -1, it'll be taken to the last item. Okay, so negative indices doesn't start at 0. You can't access non-existence indices. Okay. Our game player has an inventory that works as an array under the hood. The player knows they have a sword and a shield somewhere in their inventory, but they don't remember where. You can see the inventory drawn on the right, along with the index of each item in the inventory. Your task is to find one sword and one shield, the array using the index, then call use item on each of them so the player can equip them. One sword and one shield. How complicated do I need to be? I can be really simple with this. Okay. I was gonna make an automated way that it would go through and pick one shield and one sword, but I don't think I need to do that. Yeah, it just wants you to literally type in, grab one of them. Train tracks broken down little chunks in games and make modular tracks, draw shapes, however, slow chunks that mix a line, you need to find them. track and align them with the align function. Track with index, time with them with negative indices. Okay, tracks, all of them. Down little chunks, use them at module tracks. So trunks are misaligned, you need to find them in the tracks array and pass them to the align function. You also need to access the array by index. So does it want me to write this out or make a function to do it? And I think it wants me to write it out. So we'd do fix tracks, align tracks, -1. Then let's copy that. -1, -3, and -4. Yeah, it didn't want me to make that work in all situations, so let's just make it work in that one. Oh, dictionaries. Let's go back to here for now. Other tutorials and resources. This isn't the right thing. The built-in input callbacks, mainly listen to player input. Game give control player need to modify our 2D code. Built-in callbacks, mainly unhandled input like process. It's a built-in function. Callback using input singleton. A singleton is a globally accessible object. Godot provides access to several in scripts. It's the right tool to check input every frame. We're going to use the input singleton here, as we need to know if the player wants to turn or move every frame. For turning, we should use a new direction variable, direction, in our process function to replace the rotation plus angular speed times delta line with the code below. So replace rotation plus angular speed, replace the rotation one with this. Oh, you've been running in the background. Whoopsies. Go to the script. Replace rotation with this. You have messed up my indenting. UI left, direction is that. So UI right. This only lets you move up and down, left and right. Oh, lets you turn, okay. Oh yeah, because that's affecting the velocity, but the forward movement is still static. I can't stop moving forward, because we are still setting the velocity as the static speed up here. Which is what the up and down would probably be used to control a direction. Local variable. If the player wants to turn right, means they want to turn left. Statement if, especially if check something. Input is action pressed. Okay, let's read this. Check if a key was pressed this frame. We call input is action pressed. Takes a string representing the input and returns true if the action is pressed, false otherwise. Actions above UI left and UI right are predefined in projects using left and right arrows. You can see input going to project settings, yep, and you can remap it from there. Finally, we use the directions and as a multiplier when we update the node's rotation times delta, like this. This will ignore the code that moved the Directions of multiplier. Or the code that moves the icon's position in a circle. If you run this, you can just rotate when moving left and right, moving when pressing up. To only move when pressing a key, we need to modify the code that calculates the velocity. Uncomment the code and replace the line starting with var velocity with what's below. Well, technically it still starts with var velocity. Okay, what's wrong here? Found indent instead of... this shouldn't be indented. Okay, so this is setting the direction, part of the vector 2 to positive or negative depending on if you're pressing left or right. Rotation. Where is rotation being defined? Rotation, base part of the property of a 2D thing is angular speed times direction, which we're getting from left, right, or none, times frame rate. Okay. Then velocity is a vector 2. What does vector 2 0 mean? Okay, it's just 0, 0. So it's setting velocity to 0, 0. And this is setting direction to no direction. And then changing what that direction is depending on if there's input. If you are holding the up button, set the velocity to be up. And rotation times speed. Why? Vector up, rotated, rotation. Okay, so instead of having... no, it's still got a static speed. Why does it have... this is how delta's getting in here. It needs to have the rotation as a factor. No, but it's multiplying delta here. Trying to figure out why we need rotation as part of this velocity. If you don't have the rotation, velocity is a vector. If you don't have the rotation, it won't know which way is up. That's why it's here. And then speed is just how far in that upward direction it is. I already figured that out. It was just looking at this, it wasn't clicking. Plus velocity and 2 and a vector type. Length of 0. Yep, if the player presses the UI up, and they can control when they move up. Yep. Forward by pressing up. Same handle. The input section will get to press it in the process. The input section will use it in the process loop. Using signals will build on the relation of nodes and triggers. Okay, let's go back to here. Last lesson we used an array to represent a player's inventory. With just an array of items names, though, we can't easily keep track of the amount of each item. Instead, build a dictionary. A dictionary is a data structure that allows you to map pairs, call access key to find dictionary. Use these curly braces. Yep, French curly brackets. and separates each. Okay. Okay, we're using keys and value pairs. Dictionaries can hold any value. Match the name string, could be even a vector, although it can have all of these different keys. Keep in mind that every key has to be unique. That means we couldn't have a dictionary like the following. Holding heart 3, holding heart 8. No repeating keys. You can have repeating values though. The above sample, which key would cause an error? Healing heart. Accessing values. Inventory. Healing heart. How do you access how many gems the player has? Our item count equals inventory gems, plural. You almost got me there. You can also change the values directly, which is useful in our case for adding and removing items from the player's inventory. Yep. Okay, let's give some items to the player. We use a dictionary for the player's inventory. We need to find the inventory variable for you, but it contains no item. Give the player found items 3 healing hearts. Gems equals 9. Sword equals 1, and I think we need commas. Line 2. Wow, unexpected assign. I've got the syntax wrong. Is it equals equals? No, that wouldn't make sense. Healing hearts. There were colons here, weren't there? Was it colon? There we go, it's colon. Gonna need to remember that. Not equals, colon. Change the item count so another pickup is an item instead of the add item function for your inventory. Item name parameters and values check. We should increase the value by amount. Item name, okay. So we've got the dictionary inventory. Inventory. In the inventory, we want to give it item name and plus equal amount. I believe that is the proper syntax. Yep, okay. You can loop with arrays, you can loop over dictionaries, you can loop over both their keys and their values. Yep. Inventory. Item name in inventory. Okay, you need to do dot keys or dot. Don't know what the other one is. Syntax dictionary key. You probably, instead of needing to do dot keys, you just iterate over inventory. But if you want, and it will give these values. But if you want the keys, it will give. We'll have to test that. You can loop over inventory avails if the information for item name in inventory var item count equals item name print name plus string. Okay, so this is getting both. Yep. Now the key value function, we can call all dedicated function that displays items in the user interface. Inventory var item count equals name, add item name, item count. Mapping grid cells to units. We use dictionary to map units to other positions on a board game. That's how you typically code a board game. Grid-based RPG or a tactical RPG. While we focus on strings, keys so far, GD script, dictionaries access any value type as a key and allow you to map anything to anything. The only limitation is that every key must be unique. Using a for loop, you can use key value pairs, start a game, for run, for cell in unit cells, unit equals unit cells, add unit cell. For cell in all of these cells, get that cell, add, use the key value pairs to place units on a board at the start of the game. For cell in unit cells. Okay, that's cells that units are in. Var unit equals unit cells value. And then add the unit, name of the unit in the cell. Okay, so unit cells is a dictionary or array. Is unit cells a dictionary or array? Is the first issue here. It's not clear from this. For unit in unit cells. In unit cells cell. Okay, so unit cells is an array. Every loop of the for loop, it is getting the next unit in the array, giving it the value unit, and then adding unit cell. No, something's wrong there. Well, no, I think I'm missing something there since the variables aren't defined well in that image. Inventory and the standard keys are names of items, maps and items and players owns. You need to loop over a dictionary and display the name and amount of every item in the inventory to so called the display item function. It takes two arguments, the name and the amount. This is the name of the items. Loop over the dictionary and display the names. Okay. So we are looping over the inventory for item in inventory. So we are not doing the key. Display item. So we want the string, which should be item, and then the amount, which should be inventory item. Display item. I misspelt display. Display item. Ta-da! Got it right. Didn't flip it. A dictionary named units that maps a cell position on a grid to a unit to put there using a for loop and the place unit function. Place every unit in the units dictionary at the desired position on the board game. Okay. For okay, the vector is the key to the name that's a unit. Interesting. For position in units place unit. This is the exact same thing. Place unit position, comma, then unit type should be the string, which would be units position. Did I spell everything right? I did. Your code values a particular type. I wish... I don't know. Having a strongly typed language is a blessing and a curse. It's got good and bad. I've mostly been bumping into the bad since I'm used to a more strongly typed language, but I know there are benefits and it makes it a lot easier to work with. Arrays and dictionary strings, decimal numbers can use as types. Functions use them. Misusing them will cause errors. If you want to display the health in the interface, which is a number. Int short for integer. Yep, string. Health plus health of uncode. Looks like it would work at first glance. When running the chord, can't append an int to a string. That's funny, so it's weakly typed. So you've got a bit of the worst of both worlds. You're a weakly typed language, but yet don't have things in place to automatically shift the assumed types of variables. Interesting. Yeah, you gotta do string. That's the type of thing you'd need in, like, JavaScript, a strongly typed language. Numbers, int, float, yep. Some types are partially compatible. Oh, here we go. Most types are incompatible, or some types are partially. You can multiply or divide a vector by a number. Oh, interesting. Actually, I think we did that earlier. Possible because other developers defined that operation for you under the hood. Surprising result, you take the following division, 35 by 2, you expect to get 1.5, but... because... oh, it's classifying them both as ints instead of floats or doubles. I see. Ugh. That's yucky. It's just a zero. Adding a decimal place tells the computer we want decimal numbers. Ugh. I gotta remember to do that then. Program often struggle due to lack of understanding of types. Nope, I understand them. I'm just upset by how this handles typing. Display the player's energy in the user interface. Currently our code has a type error. We're trying to display a whole number. The display energy function expects a string. Our game shop, so I want the player type numbers to select the number of items they want to buy or sell. Now the number is an int, but the computer reads the player's input as a string. Your task is to convert the player's input into numbers. But what if the player doesn't input numbers? The int function... store it in the item count. Okay. Count equals player input equals input, not input, equals int. Why are we using... oh, I guess we want a full integer. We wouldn't want them to buy half of a crystal heart. So with hints. Default dynamic typed language. That means you can just write variables and assign them, and then reassign them with other types, unlike in some languages. GDScript, this is a valid code. Yep, you can just change what it is. Cell size, decimal number, or 2D vector. Games use grids all the time, be it for grid-based. Working with grids, you need to convert grid coordinates into positions. The cell size in pixels, you'll pick one of two types for that, float or vector 2, because pixel positions on the screen use vector 2 coordinates. Either of these two should be fine. Size, vector 2 could simplify some calculations when converting grid coordinates to game world coordinates. Cell size equals vector 2. Turn cell times cell size plus half of the size of one cell. Well, cell size, we can just add them. If cell size is a float, we get a type error. This is a float. Cell. Because it's. Wait, that shouldn't. Why is this getting a type error? If cell size is a float, we get a type error. What is cell? Grid to world. What type of variable is cell? I need to read a bunch of stuff for it to tell me that. And that's probably where the error is coming in. Using type hints, has optional hints. Oh, it does the syntax like that. Okay. Var name colon type equals. That's how you hard set type. Okay. Place the cell size with the value of another type later. This computer will not let you. And computer figure it out. Type inferencing. Okay. Okay, so you can shorthand it. That's good to know. Colon equals shorthand for hard typing. Why bother to add hints? Will prevent major errors. Yep. Okay. Variables. Correct values, but not the right hints. This is a float. This is an int. This is a string. This is a vector 2. String isn't a valid type. Does it need to be capital? Ah, for some reason string needs to be capitalized, but not the others. Most of the places I've seen, if string is capitalized, int and float are capitalized. I've not seen it be mixed like that. That's gonna be tricky to remember. Your task is to fix the values after the equal sign so they match the hint. Do I still need to put vector 2 here? It's funny that for vector 2, you need effectively to write out vector 2 twice. Well, that's all for that. I thought there was a bit more. But that did give you the basic data structures, basic array work. There should be a lot more down once we get to the references. Okay, we're still in way up here. Engine details, community, class references. Whew. Starting to get a bit tired. You can search for information about class signal by I think I'm gonna remember that. Control clicking so we can get rid of this. Gonna keep that. Gonna keep this open. I am getting tired. As it turns out, doing this is mentally taxing. Do we want to go to playing a game, or am I just gonna call it a night? I think I'm gonna call it early. I might do some more stuff on my own if I feel like it, but I gotta be up tomorrow, so I'm just gonna call it early. And say thank you to anyone who stopped by. And till next time, see you when I see ya. Not sure if I'm still going to be programming next time, or, well, I don't know if I'd fully call this programming, but kind of. Or if I'll be playing a game. We'll see. So, till next